Welcome to Star Chat, the podcast where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm excited to share some fascinating space news with you today. We have two amazing stories to dive into, but first, let's talk about a mysterious phenomenon that has astronomers scratching their heads. Imagine a galaxy where stars are being born at an incredible rate, only to be destroyed by massive explosions. This is what's happening in the galaxy SKM 111-1262, a red dwarf star system that's home to some of the most extreme space weather in the universe. A team of scientists has discovered a coronal mass ejection, or CME, emanating from this star, which is moving at a staggering 5.37 million miles per hour. To put that into perspective, that's much faster than any CME emitted by our own sun. This explosion would be devastating for any planet orbiting the star, stripping its atmosphere and leaving it exposed to harmful radiation. But that's not all. We also have another intriguing story about an isolated galaxy where stars are being formed at a rate that's unheard of in the local universe. The galaxy is called CKM 11262. No, just kidding. It's actually an unnamed galaxy that scientists are studying using advanced telescopes. In this galaxy, researchers have found evidence of a massive star-forming region where new stars are being born at a rate that's 10 times higher than in our own Milky Way. This discovery has implications for our understanding of how galaxies evolve and how stars form in different environments. However, I must correct myself. It seems I got ahead of the story. Let me start again from the beginning. Welcome to Star Chat, the podcast where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm excited to share some fascinating space news with you today. We have two amazing stories to dive into. First, let's talk about an isolated galaxy where stars are not being formed, but actually, it's a story about scientists trying to understand how stars form in the universe. They've been studying a red dwarf star system and its ability to host planets that can sustain life. A team of scientists has discovered a coronal mass ejection, or CME, emanating from this star, which is moving at a staggering 5.37 million miles per hour. This explosion would be devastating for any planet orbiting the star, stripping its atmosphere and leaving it exposed to harmful radiation. The star in question is called CKM 11262, a red dwarf that's smaller and dimmer than our own sun, but much more magnetically active. These types of stars make up most of the stars in the Milky Way and host the largest number of known planets, roughly the size of Earth. Because their habitable zones lie much closer to the stars, these planets are likely subjected to far more frequent stellar storms, which could have a significant impact on their ability to sustain life. Scientists are working to understand whether rocky worlds orbiting close to red dwarf stars can hold on to their atmospheres. And the answer to this question could have major implications for our search for life beyond Earth. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We've got a fascinating story to share with you now, one that challenges our current understanding of the universe and its large-scale structure. You see, astronomers have been trying to measure the speed of our solar system as it moves through space, and the results are nothing short of astonishing. Imagine you're in a car, driving down a highway on a rainy day. The raindrops hitting your windshield seem to be coming from all directions, but if you look closely, you'll notice that there are slightly more droplets hitting the front of the car than the back. That's because the car is moving forward, creating a sort of headwind that affects the way the rain appears to fall. Astronomers used a similar principle to measure our solar system's speed. They looked at distant radio galaxies, which produce strong signals at radio wavelengths. By analyzing the distribution of these galaxies, they found that there are slightly more of them in the direction we're moving than in the opposite direction. This creates a kind of headwind of radio galaxies that can be detected with sensitive instruments. The team of astronomers, led by Lucas Boume from Bielefeld University, used data from 2 radio observatories and the low-frequency array to make the first-ever precise count of radio galaxies and their distribution. And what they found was remarkable. Our solar system is moving through space at a speed that's more than 3 times faster than current models predict. This result has significant implications for our understanding of the universe, particularly when it comes to the standard model of cosmology. You see, this model assumes that matter is distributed relatively evenly throughout the universe, but if our solar system is indeed moving this fast, we may need to question those assumptions. As one of the researchers noted, if our solar system is indeed moving this fast, we need to question fundamental assumptions about the large-scale structure of the universe. Alternatively, the distribution of radio galaxies itself may be less uniform than we thought. Either way, our current models are being put to the test. The implications of this discovery are still being explored, but one thing is clear: our understanding of the universe just got a whole lot more interesting, and who knows? This could be the start of a new era in astrophysics research, one that challenges our assumptions and pushes us to think about the cosmos in new and exciting ways. Welcome back to Star Chat. We've got one more exciting story to share with you before we wrap up today's episode. NASA has been making headlines lately with its innovative missions and collaborations with private space companies. Speaking of which, let's talk about the ESCAPADE mission, a twin spacecraft venture that was launched recently with the help of Blue Origin. The ESCAPADE spacecraft, built by Rocket Lab, will study how Mars's environment is impacted by the sun and solar winds, providing crucial data for preparing human exploration of the red planet. What's fascinating about this mission is that it was completed on a relatively low budget of $80 million, with Rocket Lab building the twin probes in just 3.5 years for $57 million. This collaboration between NASA and private space companies like Blue Origin and Rocket Lab could set a precedent for future interplanetary missions. It's a great example of how public-private partnerships can lead to innovative and cost-effective solutions in space exploration. The ESCAPADE mission is also significant because it will help us better understand how Mars became a desert planet and how solar eruptions affect the Martian surface. As NASA continues to push the boundaries of space exploration, we can expect more exciting missions like this one in the future. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.